Functions and types of functions. A function is a relationship between an input and an output. We send an input and some operation takes place inside and gives an output based on the operation which has occurred inside. Suppose if you have an operation which is 5x, and if we give an input as a 5, so 5 times 5 will give us an output of 25. Suppose the same way, if we give an input of -1, 5 times -1, so we'll get an output of -5. For example, this f of x is a function. It is a representation of a function. F of x will be equal to 8 minus x. And now, if we have to find f of 2, then we replace x by 2. So here too we replace x by 2. So it will be 8 minus 2. So it will be equal to 6. F of -3 if you have to find. So we are replacing x by -3. So on the right side also replace x by -3. So it will be 8 plus 3. So it will be equal to 11. Now our input values, that is, these are our input values. 2 and -3 are our input values. Our input values, we'll represent it as a set A. And our output values are here 6 and 11. These are the output values and we represent them as set B. So now we know that a function is a relationship between a set A and a set B. Now let us see the basic requirements for a relation to be a function. That is, every element, first thing is, every element in set A has to have one and only one. And only one image in set B. The second thing is, no element in set A must be left out. Or in other words, we can say that no extra elements must be there in set A. No extra elements in set A. Now we'll see the types of functions. Suppose if we have y equal to 2x and our set A will have the elements as, we'll just give some elements 1, 2 and a 3. So automatically our set B will be equal to 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, 2 multiplied by 3 is 6. So if you are representing it over here in a set notation, this is the set A and this will be the set B. That is, here we have 1, 2 and 3. Here we will be having 2, 4 and a 6. So this 1 is mapped onto 2, 2 is to 4 and 3 is mapped onto 6. So now both the conditions are satisfied. Every element in set A, all these elements in set A has only one element, that is one image in the set B. No element in set A is extra over here. All the elements have a mapping over here. And one element is mapped onto each and every element in set B. When this happens, this is called as a one-to-one function. It is, every element in set A has an image in set B. Then it is called a one-to-one function. This is the first type of function. Next thing, suppose if the function y equal to x squared. That is, if you take our values for the set A as 2, -2, 0, 1 and -1. If we take these values, what will our set B will have? When it is a 2, 2 is 4. -2 also will give us a 4. 0 will give us a 0. 1 and -1 will give us a 1. So now when we represent it in a Venn diagram, this is the set A and this is a set B. So we'll write -2, 2, 0, 1 and minus 1. And these things are 4 images. So if you take 1, 2 and negative 2 will have the image as 4. 0 will have the image as 1. 1 and negative 1 will have the image as. Now let us see whether it is a function. Our first condition is it has to have one and only one image. For every element in A, has to have one and only one image. So minus 2 has one image which is a 4. 2 has also one image which is a 4. This 0 has one image. So 1 and negative 1 also has one image only. So every element in A has only one image in B. So this is also a function. But many 2 are mapped onto 1. So this is called as a many to 1 function. Now continuation of our previous one, y equal to 2x. We have a same set, that is 1, 2 and 3. So we have, this is a set A and set B. We have it as 2, 4, 6. And so this one is mapped onto this. This is, in case if there is an extra 8, then let us check whether our condition of a function is satisfied. Every element in set A has only one and only one image. That is, 1 has a 2, 2 has a 4, 3 has a 6. And there are no extra elements in A. So this is also a function. Then the next thing is y equal to square root of x. Now let us take our values of x as 4 and 9. When x takes the value 4, square root of 4 is less or minus 2. So it is a 2 and a negative 2. And in the same way, 9 means it will be 3 and a negative 3. So this 2 has an image like this. It has to have, this 4 will be 2 and negative 2. 9 will be 3 and negative 3. So our set A has 2 images. See, 4 has 2 images, 9 also has 2 images. So it is not a function, it is just a relation. So only when it is a one-to-one function and many-to-one function, it will be a function. Other than that, others are all called relations. Now we'll see more about one-to-one functions. We'll take a small example, y equal to x plus 2. So that is 1, 2 and 3. So it gives our images 3, 4 and 5. This we saw this way when the arrow is, it is a function f. If we take, that is f of x equal to y equal to x plus 2. So this is a function. But when we take the reverse of it, that is f inverse. F inverse of it means this becomes the object. Like for example, this is a function f. If we just interchange it and write, so we have 3, 4 and 5 over here, 1, 2 and 3 over here. This is for f inverse. When it is f inverse also, it becomes a function. That is, 3 is the object now and these are the images. So f inverse also is a function. So we have to understand that when it is a one-to-one function only, f and f inverse exist. Many-to-one function, that is y equal to x squared. So negative 2 and positive 2 will give us an image of 4. Negative 3 and positive 3 will give us an image of 9. And this is a many-to-one function and we have seen that this is a function for f. Now let us check for f inverse, whether f inverse is a function. So now just reverse it and draw the figure. That is 4 and 9 over here, negative 2, 2 and negative 3 and 3. So 4 will be mapped onto these two and 9 will be mapped onto 2. So now, is f inverse, this is f inverse. Is f inverse a function? Let us check. Our first condition is every element in the set A needs to have only one image. But here, an element 4 has 2 images. Element 9 has got 2 images. So this f inverse is not a function. So we understand that only if a function is a one-to-one function, then F inverse exists. Otherwise, we will not be able to find the inverse function.